Hello and welcome to Amateur Radio Topics. I'm Kevin, VK6LW Whiskey, and in this episode I'd really like to primarily talk about receive antennas. So I've been using receive antennas for many years. Probably started off with beverages and had a deal of success with these. Beverage is quite a good antenna. It's not a difficult antenna to build. It's quite forgiving. You can make it unidirectional by terminating one end, and simple transformer at the feed point end, normally about a 4:1 binocular ferrite core at the feed point, straight into either 50 or 75 ohm coax back to the shack. So with a beverage, there's really not much to go wrong. If you want it to fire in one direction, you terminate the far end in a nominal resistance, normally 450 ohms or 600 ohms, depending on the height of the beverage, and that will give you a unidirectional pattern in the direction of the wire. If you want it to be bidirectional, well, you just eliminate the resistor and have the far end unterminated. And this normally results in a couple of things. You probably get a bit more noise pickup on the beverage from the sides and from the rear. Sometimes it's useful to have a unidirectional beverage. Sometimes you can have something set up and it's running both ways. You're getting two directions for the price of one, but you don't get any front to back ratio. Obviously you can get interference off the back of the antenna as well. So a lot of guys want to set these up so that they're in actual fact unidirectional. You can actually build a reversible beverage. That's a slightly more complicated setup, but I've generally speaking just either use them either unidirectional or bidirectional, depending on maybe what contest is coming up and whether or not I really need any rejection off the rear of the beverage, that sort of thing. So I'm probably fairly fortunate here. I can run beverages out in two directions for about 150 meters in each direction at right angles to each other. So it gives me either 2 or 4 directions I can switch between depending on the mode of the beverage. So not a bad antenna and a useful yardstick as we move on to what else is available from receive antennas. The output from a beverage is normally quite enough. I've never used one with a preamp other than the preamp that's on the radio. So the ICOM 7610 has got 2 preamp settings, 1 and 2. Quite often on the low bands, 160 or 80 meters and 40 meters, you really only need the first setting of preamp. You can also use the beverage on 20, 15 and 10, although obviously not quite as effective, but they're not a bad receive antenna if you've got some really noisy conditions or local storm conditions, that sort of thing. They can be useful on the HF bands depending on what sort of condition the bands are in. So from the beverages, I essentially moved on to other types of receive antennas that were going to help me with my SO2R type contesting, where I need to transmit on one radio and listen on another radio. And I set up some receive antennas further on away from the transmit antennas, probably about 120 meters away from the transmit antennas. I set up some receive antennas, things like the extended double ZEP antenna, which I've managed to make into a multi-band type antenna for 40 through to 10, and also a tri-band off-center fed antenna which works on 3 bands, 20, 15 and 10, and passably on 40 meters. And I use these as receive antennas mounted at a height of around about 10 to 15 meters above the ground. And they're pretty effective. They're a reasonable distance away from the transmit antennas. I've got receive bandpass filters set up for each band, which are automatically switched as I go through the bands on the 7610. So that's quite good. I get a pretty good rejection on those, so I can be on 20 meters and listen on 15, or 15 meters and listen on 10, etc., etc. Obviously, sometimes the second harmonic can be a problem if you're trying to do what I've just described, but you can quite often avoid that, particularly with big contests like CQ Worldwide, where you can operate up and down the band. You can avoid the second harmonic without too much trouble. So those receive antennas are actually pretty good as receive antennas. They're not bad transmit antennas either, but that's something I'll probably talk about in a further episode. So I arrived at a situation where I've got a couple of beverages and a couple of HF receive antennas. So I'm covered on the LF bands with the beverages, and I'm covered on the HF bands with the higher EDZs and the off-center fed antennas. And then I kind of got interested in trying to do a little bit more with these receive antennas a few months ago. And I did a podcast with Steve, VK6LW, which is quite interesting because he has got a fantastic setup up there in VE6. It's a remote operation. And he had a lot of beverage antennas. And he gradually replaced all his beverage antennas, above ground beverage antennas, with beverages mounted near to the ground. When I say near to the ground, they weren't quite on the forest floor. They were mounted on strips of logs and wood and whatever. So they might have been, somewhere around about 10 to 20 centimetres off the ground floor. They weren't completely buried in the undergrowth, that type of thing. And he's had quite a bit of success with these bogs, or bogs near to ground. Or bogs, I think he was calling them bogs on logs, something like that. But they work pretty well. And he also developed a preamp for them, a high impedance preamp, which if you go onto his YouTube site, VK6LW, and have a look, there's quite a bit of information on there. He makes the printed circuit board information freely available. You can order those in. You can make your own boards up. And he found with these beverages on ground or beverages on logs on 160 metres, he really needed a preamp. He needed a low noise preamp, and he adapted a high impedance preamp, which is previously used with like an 8 circle array for 160. And he's had a great deal of success with them. Very good. So I kind of got a bit inspired by this. I thought, I've got to mess around with this and see if I can put down these bogs or these bowls and see how it works. Because it'd be nice if I didn't have to worry about maintaining the beverages. These wires on the ground are a little bit easier to do, and the preamp sort of makes up the difference. And this was okay. I ordered the parts in. I got the printed circuit boards. I built a couple of these units up, and they're quite a neat little preamp. One of the problems I had on 160 essentially was the breakthrough from local broadcast AM transmitters, not that far from here. I'm talking about maybe 10 or so kilometres away with some pretty high power, 50 kilowatts, that sort of thing. So then I got into this cycle of, I really need to build a BCB filter to block these out, a high pass filter, so that I don't hear the medium wave stations over the top of this, and it gets rid of some of the crud and that sort of thing. And to be honest, that's still a little bit of work in progress. I wasn't too keen on the filtering side of things, because in my situation, if I want to use these antennas for an SO2R operation, I can't really disable the receive antenna on transmit, because I need to listen to the receive antenna on another band. So my application is actually slightly different to what some of these other guys are doing with it, where I know they disable the receive antenna on transmit. Anyway, quite an interesting exercise, and certainly with the preamp in place and with my bandpass filtering in place to get rid of the BCB interference, they were pretty effective with the beverages on the ground. And I played around a bit with those and thought, yeah, this is okay. And then I started sort of looking around on the net and seeing what other information I could find. And there's quite a few articles on the net about loops on ground. And I'd never actually really tried that. And I thought, this might be a good idea. It's a good opportunity now, while I'm in this mode of testing out receive antennas, to see how a loop on ground is going to work. So put down a couple of loops on ground. One was 15 foot aside, or around about 60 foot in total length. So not a huge loop by any means. Around about sort of 18 meters, and fed with just one of my old beverage transformers, a 4-to-1, but I actually changed that later on to a 7-to-1, which seemed to actually help a little bit. So the 18 meter circumference antenna was okay. I found that I could hear stuff on it okay. It worked pretty well on the HF bands. It was okay on 40. It wasn't so good on 80 and 160. The output was a bit down. And because I didn't really want to use a preamp with it, for all the reasons I mentioned before, it was probably the output was a little bit low. So I built a bigger one. I built one that was twice the size. So it's got 36 meters of wire in it altogether, and put that down. And because that was much better on 160, it was much better on 80. It's pretty good on 40, but the performance on 20, 15, and 10 wasn't quite as good. This is just testing. I'm just reporting back on what I found. But it was workable on 20, 15, and 10. But it probably wasn't quite as good as my above ground receive antennas that I had. So I was sort of looking for something maybe a little bit better than that. Played around with it a little bit, and worked out that these loops that I had on the ground were a little bit directional in nature. You could notice more gain or perceived gain off the sides of the antenna. Now, to bear in mind, these antennas don't really have gain; it's all relative. So they're a lossy antenna. This is what makes them actually quite useful on receive, and it's all about signal to noise ratio. It's not really about the absolute gain of the antenna one way or the other. It's about how the signal to noise ratio is represented on that band at that time. And I certainly found on the low bands the signal to noise ratio was very good. It was at least as good as the beverages on the ground, and probably about the same as the beverages above ground as well. In fact, I would say they were probably quieter than the beverages above ground. So that was kind of interesting, just testing not necessarily testing scientifically, but testing on the air in everyday use for a few days or weeks, and just seeing how the things felt and worked. So my overall impression with the loops on the ground, yes, very good antenna for signal to noise ratio, and probably slightly lower noise figures than the traditional beverage. So, and I stuck with those for a while and played around, and had a chat with my friend Steve, VK6VZ. He messed around as well, putting one down. He was very happy with the performance on 40 meters, etc. So I'll try some different lengths as well with these loops on ground. And so then I thought I'd do a little bit more modelling on Easy Neck. Now, Easy Neck is not necessarily geared up to model wires on the ground, but it does kind of work. And I did find that I needed to mess around a bit and make sure that I had the ground conductivity set correctly in Easy Neck for these antennas, because if you model these over, say, marshy or heavy clay soils with a high water content or whatever it is, you're going to get one result. If you live on top of a hill like I do, which is like a rocky outcrop, then there's no ground conductivity there that's worth talking about really. It's not clay, it's rock, but I'm high up, and so consequently you need to program that into EasyNet, which is fairly easy to do, and you get a different result, particularly with something on the ground. So I thought I'd try something a bit different that I hadn't really seen anywhere else before. Somebody may have done it, who knows? There's no such thing as a new idea in this world. But I thought I'd take the same length of wire, the 36 metres, or I think it's 36.5 metres, and I'll turn it into a delta loop. And I put the top at around about 7 metres height, 6.5, 7 metres height, in a convenient tree. It's quite close to the shack here, so it's good for testing. I use the same Ballon transformer, 7-to-1, that I was using on the beverages on ground, and I'll put the base wire on the ground. So essentially, I've got a delta loop, and broadly speaking, the delta loop has probably got more or less a right angle at the top, and the two wires slope down to ground level. I've just got them held in place with a few logs or a couple of rocks or something, and then I've got a base wire that runs along the bottom. So it's a classical delta loop, and not too scientific. I just put it up the way that it sort of works within the topology here and the height of the tree, etc. So I think I ended up with about 15 metres or so on the ground, and the rest of the wire was taken up. Actually, no, that's not quite right. I'll have to check my figures on that. But I certainly ended up with a nice delta loop shape using 36 metres of wire. Might have been about 15 metres on the ground actually, and about around about 21 metres taken up on the sides. Some of this you'll find I've catalogued some of this actually on my Instagram page. So if you pop onto my Instagram page, you'll see these antennas. I haven't got this right in front of me at the moment. I'm just doing a podcast, thinking about what I've actually done. But the point I'm trying to make actually with this is that it isn't that critical. Find a tree, put a delta loop up, string the wires out, it's going to work. It doesn't matter whether you've got 15 metres on the ground or 16 metres on the ground. It's not relevant really. I just needed some wire on the ground. And I put one of these up running essentially east-west. So the EasyNet modelling tended to indicate that probably the maximum directivity was going to be within the plane of the wire. In other words, it's off the ends of the wire on the low bands. This is a really important thing to think about here. So on 160, 80, certainly on 160 and 80, the maximum directivity is off the ends of the wire. Anyway, I fired this thing up, I had a listen on it, and I thought, yeah, this sounds pretty good. Compared it with the transmit antenna, compared it with one of my raised receive antennas, and on 160 and 80, it was much better than the transmit antenna on certain signals, and it was much better on certain signals on 80 metres as well. And when I say it was much better, I'm talking about the signal to noise ratio. So you can get a situation where, particularly on 80 metres, I've got a dipole up at 25 metres high. Well, that's a pretty good antenna. It's a pretty good receive antenna. It's quite low noise. It's not a terrible antenna. It's not a vertical, for example, with the attendant noise issues. So I was comparing against that in a lot of instances, but what I'm looking for is signal to noise ratio. And I was pleasantly surprised to find on 80 metres one morning. I worked some guys on 80 at my sunrise, US long path and into the Caribbean on long path, and on this loop, this 36 metre loop with the 15 or 16 metres or so on the ground and the feed point in the middle of the run on the ground. And I could hear stuff on that loop that I could not hear on my 80 metre dipole, which is great. And I couldn't hear it on my other receive antennas either. So, and then I did a little bit more 160. I found an opening one morning and I was working Europeans on that. And then I found on the 160 metre dipole that the signals weren't quite as good. So I put another loop up at right angles. So now I've got two loops in the same tree. They're not connected at the top, they're not connected at the bottom. There's just two loops in the same tree. One runs north-south, one runs east-west. So when I did the same tests over again and I got some openings on 80 and 160, I found I had a little bit of directivity back and forth, which was really encouraging. And I found that on 160, when I had an opening, and there's not been too many of these lately, in my morning, that the signals from Europe were better on the north-south position than they were the east-west position, which kind of makes sense because quite often the signals here in Perth come in on a northerly direction. When you model these loops on EasyNet, they don't look fantastically impressive, and they've got a little bit of high angle property. You know, they will pick up high angle signals. They're not just completely low angle, but that can be an advantage in a way on the low bands. Quite often signals do come in here on a higher angle at sunrise and sunset, and I've found that out by comparing with the transmit antenna, which is essentially a high angle receive antenna, and that quite often will pick up signals at a high angle on the low bands on occasions. Depends on band conditions. So anyway, overall, I was pretty happy on 160. I was getting some directivity, and I found that I got the same results on 80 metres. I could hear these guys from the long path on the east-west loop, and then when I switched to the north-south loop, they weren't as strong. But if I had somebody from Europe on the short path on Europe on 80 metres, I could hear them on the north-south really well, not quite so well on the east-west. It's all working the way it should work. So then we move on to 40 metres. I think, well, these things have got to work on 40, and yeah, they work really well on 40. 40 metres is just great with them. I've got a 2-element beam on 40 metres, and the signal to noise ratio on these loops is better than the 2-element beam. It makes the signals more readable. There are times where the 2-element beam will still outperform. It just depends on, as I say, sometimes the band conditions. But generally speaking, these loops on 40 metres are really good and really nice directivity. There's probably, you know, when I flick back some forwards, there's probably there's a good sort of like 2 to 3 S points back and forth directivity on the loops. So, will they work on the HF bands? That was a big question because that's what I really wanted. I wanted some loops that would work on the HF bands. And 20 metres, they're pretty good. Yeah, really happy with the directivity on 20 metres. But a strange thing happens. If you model it in EasyNet on 20 metres and 15 and 10, you notice that the way the pattern operates is broadside to the loop. So it's off the sides of the loop, not off the ends of the loop. And you also get a pattern where the lobes are split up. So the lobes split up into like more of a cloverleaf type setup. However, I'm really happy with the performance on 20 metres. I can certainly use them. I can go on 20 metres, use my, I've got X-beam, 2-element X-beam stacks on 20 metres. It gives me a pretty good signal. Obviously they work very well. You can use them as receive antennas, and there's no question of that whatsoever. But the loops are very good at filtering out the crud in the background. The signal to noise ratio is excellent. There's nothing so far that I could hear on the stacks that I can't hear on the loops, albeit that it's going to be a lot weaker on the loop, but I've got no noise. So in a contest environment, this is a big deal, because mainly in the contest you're battling against noise continuously for however long the contest runs on for, and it's the noise that wears you out, I think, in the end. So it's kind of interesting. So 20 metres, very happy. Go to 15. Performance on 15 is still good. With the same sort of characteristic I was getting on 20, and also on 10 metres, which is a surprise. I thought this might be just not quite the right dimensions for 10 metres. Works well on 10 metres as well. So I've managed to arrive in a circuitous way at a loop antenna receive system with two loops, two delta loops mounted at right angles, two separate feed systems that I can switch between, RG6 coax run to the shack, 7-to-1 balun, with a receive system that I can use on 160 metres to 10 metres. Now these loops are only about 25 metres from the transmit antenna, maybe a bit closer with some of the way the wires work out, but they're pretty close to the transmit antenna. So I thought, well, I'm just going to try these out and see if I can, how I'll go with SO2R, put the bandpass filters in place. The bandpass filters, will filter out the crud, hopefully. Let's see if I can go on 20 metres and 15 and 40 metres and 20 and whatever. Use the loops to receive, and let's see what happens. And I was kind of like amazed that there was virtually no breakthrough between the bands with the receive antennas this close to the transmit antennas. Now, I haven't tried putting these down 120 metres away from the transmit antennas. That's my next project. I probably will. Probably put a loop up down there at the bottom of the block and think, well, let's just see how this goes. Let's see how much breakthrough I've got. But it's very encouraging to think I can possibly now use these as receive antennas on all the bands and be able to transmit on one band and listen on another, because that's obviously the basis of SO2R, or two bands interleave QSOs. So that's what that's in a nutshell. That's what I've been working on, and it's been a really interesting project. Now, at the moment, it's probably this is probably about as far as I can take it right now. I think the next thing possibly is to relocate these loops and get them away from the transmit antennas a little bit more. But honestly, even if I didn't and I had them the way they are, they're going to be really useful, and they're useful to a point now where I'm thinking probably don't really need the beverages now. I can probably get rid of those 150 metre beverages, which do require a little bit of maintenance. They've got to be a certain height to keep out of the way of the kangaroos. If they're not at least 2 metres high, you've got a problem. You've got kangaroos, jumping up and getting caught up in them and all that sort of thing. And there's always the potential for something going wrong with the beverages. You're continually out there fiddling around, sorting things out sometimes. So quite possibly I'll get rid of my beverage antennas. Quite possibly I'll get rid of the beverages on ground. And I'm probably going to continue on with these loops, which so far, as I say, I'm really happy for all the bands 160 through to 10. And then, of course, the other thing that comes to mind is, well, they're very low noise. Very low noise. So guys that are operating in circumstances where they're in a noisy location, could this be an answer to their problems for receiving on all the bands, really? Because you hear a lot now of, well, my noise levels have gone up, I've got broadband noise, I've got this noise, I've got that noise. We're living in a noisy environment. These loops mounted on the ground, and I'm sort of calling them delta loop half on ground, which is what it is. Could that be the answer? Because you have a separate receive antenna and you have a transmit antenna. You don't have to be interested in SO2R or anything like that. It's just useful to have a separate receive antenna, and the footprint's not that big. Okay, I've got two big loops with 36 metres in each one, but you can make a half-size one, and you're going to get pretty good performance from 80 metres all the way through to 10 metres, and then it's quite a small loop. So instead of having 16 metres on the ground, you might only have 8 metres on the ground, and that's going to fit into most backyards, and you could possibly even still arrange two at right angles, and you can switch them and get some directivity. So there we are, loop antennas for receive. If nothing else, it's a fun project, and it's still a little bit in progress for me, but I'll report back as I go along. I did use them recently in the Commonwealth contest, and was very happy with the performance of them in the Commonwealth contest. Worked really well, particularly on 80 metres and 40 metres. They cut the noise right out. We get a lot of noise here on 40 metres from, say if I'm beaming to Europe on the short path, I've got to beam across Asia and Europe to get to the UK and that sort of thing. So there's a lot of noise. There's a lot of noise that's not necessarily amateur radio-based noise that's coming in on that path at that time, on that short path. And I found that the loop was really good for this. I could switch between the loops, and I could get a bit of differential, and I could get rid of some of that noise. So and I'm sure there's lots of other things. There's lots of other experiments you could do. You could phase the two loops up and switch the phasing around between them. You could try connecting them both together and doing something there. But it's nice to have two loops you can switch around with. A really simple switch in the shack, that's all you need. You don't need any fancy control boxes, just two coax lines coming in. As I say, a lot of this now is finding its way onto my Instagram feed. So if you go onto VK6LW and have a look on Instagram, you'll find me. And there's quite a few antennas I've put up there with some details, with some dimensions, and with some information about what I'm doing, and some audio clips as well. So you get an idea by listening to those short audio clips on Instagram exactly how the antennas are working. And it's not just the loops on ground. I'm putting quite a few of the other antennas up onto Instagram so people can have a listen about what the bands sound like for VK6 and what I'm doing with these antennas more recently, the antenna experiments. So I think that's about it for now. Wrap that one up and look forward to the next podcast. Might discuss a little bit more about some transmit antennas and some other projects I've been working on here. But for now, 73's from me, Kevin, VK6 Lima Whiskey, and also VK6 Tango if you find me in a contest. Thank you.